Hey guys, this will be the last video for your 6-4 review. So, oh, that glare is pretty rough right there. I apologize. Let me try to get that out of the way. Nope, that ain't going anywhere. All right, so we're just gonna have to deal with it. I know it was bad before. So now we're looking at just graphing the functions. So we're gonna graph f of x equals 2 times 3 to the x. So quick idea sketch. Remember how we have an idea of what it should look like, then we'll be more specific. This is positive, so we know we're on the top side. 3 is bigger than 1, so we know we're going away. So we'll have a graph that looks something like that when we're done. Now let's jump into it. Evaluate the function for x equals -2, -1, 0, 1, and 2. So when you're going to go through and do this, you're just going to have to plug them in. You plug in -2 for x, so this would be 2 times 3 to the -2nd. -1 for x, this would be 2 times 3 to the -1st. F of 0, 2 times 3 to the 0, 2 times 3 to the 1st, and then 2 times 3 to the 2nd. Okay, this is all going to be calculator work. So you're going to have to bear with me for 1 second. I'm not going to switch to Desmos on screen. I'm just going to do it on a calculator. I will switch. I'm not going to switch to Desmos on screen. Sorry for that flip-flop. But you guys should be able to do this on Desmos right now. So 2 times 3 to the -2nd. And I will accept decimals. This one is actually going to be a repeated decimal. 0.2 repeating. And then to the -1st. That's 0.6 repeating. Notice it ends up doing a 0.7 at the end. That's only because it rounds. 2 times 3 to 0. We should already know this is going to be the y-intercept when x is 0. So this is going to be 2. 2 times 3 to the 1st. 2 times 3 is 6. 3 times 3 is 9. And then times 2 is 18. So now we can come over here and start graphing. -2, 0.2. So very, very low. -1. 0.6, 2/3 of the way up. 0, 2, 1, 6, and 2 all the way up here to 18. And then we'll connect it with a smooth curve. The key is making sure as we go down, you make this look like it's going to come very, very close to 0, but we never actually hit it. Okay? If I see you cross over 0, you're going to lose a point. Okay? So now, graph the 5 points and connect with the smooth curve. Done. Identify the domain and the range. The domain. So we went over this in class. This is pretty much always going to be all real numbers. You can plug any x you want in, or you can see the graph goes as far left and as far right as you can imagine. So the domain is all real numbers. The range. Well, it gets really, really close to 0, but never hits. So that's why I put an open circle there. You can't really see that on the screen. Let me do that again. There's an open circle at 0. Now, you see the picture of my graph exists up here with all of these y's. So in other words, my graph represents all of the y's greater than 0. So hopefully this one makes sense. This should be a real easy handful of points on your test. So, you get a couple points for here, a point for your graph, a point for your domain, and a point for your range. This is easily a 4 to 5 point problem. This should be one of the problems that really helps improve your test score. All you have to do, f of 2 means plug in -2 for x, -1, -1 for x, get your answers. Please make sure this is all you plug in to Desmos. You don't plug in this side. It's just this part, okay? Saw a lot of people making that mistake. And then the last problem is just going to be a story problem. The population of rabbits on a large island doubles every year. On January 1st, the population is 150 rabbits. Which equation can be used to find the number of years X it will take for the population to reach 4,800? So we're just going to write, and I'm going to look at these. I'm just going to think about y equals a times b to the x. I know it's going to look like this because it's telling me it doubles every year, okay? So if it's doubling every year, it's telling me I'm going to have exponential growth. Every year it doubles and then doubles and then doubles. So we have to remember what this formula represents. Y, the final amount, is, which is the equals. A is our starting amount. B is how we are growing. So this is our growth factor. And then X is the number of times we grow. Sorry if you can't really see that, but so the final amount is the starting amount times your growth factor to the number of times that you're going to double. So let's see what they give us here. The population on January 1st is 150. Which equation can be used to find the number of years it will take for the population to reach 4,800? So here's everything that they told us. We know it's going to double. We know we're starting with 150. We know we're going to go for X years, and we want our population to reach, or our final amount to be 4,800. Right there gives us our equation. 4,800 should equal 150 times 2 to the x. 4,800 rabbits will equal 150 doubled how many times? The number of times it doubles is the number of years it takes, because we saw it doubles every year. So we're trying to see, we start with 150. How many times do I double it till I get to 4,800? That would be the solution. But look, we're not trying to solve it. We're just trying to come up with which equation. And it would be B. 4,800 is 150 times 2 to the x. Okay? You will have a problem a lot like this, and there's going to be some other problems on there that they're not surprises, but they're applications that look a lot like air practice questions. So good luck on your test. Please make sure you study and come see me if you have any questions. Good luck, guys.